Question 28F. A charity seeks to raise money by telephoning people at random from a call centre and asking them to donate. Over the years, this charity has found that the amount of money raised, A dollars, is related to the number of telephone calls made, N. A graph of this relationship is shown. It cost the charity $2,100 per week to run the call centre. It also costs an average of 50 cents per telephone call. So part 1, write an equation to represent the total cost, C, of running the call centre for a week in which N phone calls are made. So that one's a fairly straightforward one. C, that's the cost, is equal to, so we have a fixed cost here of $2,100. That needs to be paid basically up front. And every telephone call is going to cost 50 cents or half a dollar. So we'll leave everything in dollars, of course. So that's one of the things, just it's a subtle point, but this 50 cents really needs to be expressed in dollars because all amounts are in dollars. So we use the same units. So this will be plus 0.5 N. So part 2, by graphing this equation on the axes above, determine the number of phone calls the charity needs to make in order to break even. Okay. So this is a linear equation. This C equals 2,100 plus 0.5 N. This is the y-intercept, 2,100. Even though it's written back to front, in fact, I could write it. I'll just write it actually maybe off to the side here. I could write it like this, 0.5 N plus 2,100. So this is in the form y equals mx plus c. So gradient is 0.5 and the y-intercept is 2,100. So 1, 2, 3, 4, 5. Okay, so it looks like we're going to be starting from here. Okay. And the gradient is 0.5 N. So in other words, for every 200 we go across, we go up 100. Okay, so 1 there. Okay, for every 200 across, okay, we go up another one. Okay, 200 across, we go up another one. Okay, 200 across, we go up another one, and so on. Okay, so it's an easy way of graphing without even having to use a table of values, which is very handy. Okay, so just interpreting what it meant, what 0.5 N means. Okay, so there's our line that represents cost. So this is our cost. And we need to work out where the break-even point is. So that's the point of intersection. Okay, so that's just here. And that will be 700. Okay, so 700 calls need to be made. Okay, determine the number, 700 calls.